to all the respected faculty members present here. My name is Shubhadeep Karmakar, and I, along with my project members, Aviraj Paul, Amandeep Vashisht, and Kalpeshwar Paul, have made this video about a final year project titled Air Pollution Monitoring and Prediction using IoT and Machine Learning. So this project is actually being guided by Dr. Navajit Sekia sir and Dr. Siddhanta Bora sir. So let's get started. So these are the contents of this video presentation. We'll be covering these individual portions. If we move forward now. So this is the introduction part. So basically in current scenario we can see that industrialization and urbanization is on a steep rise, and because of these reasons basically the quality of air that we're living in, that is actually being compromised, and prolonged exposure to these conditions has actually led to pulmonary diseases. So through this project we basically focus on developing a system that actually combines the power of Internet of Things and machine learning to ultimately monitor the value of the air quality, which is basically nothing but the air quality index in real time, and along with this give a predictable value of AQI for the upcoming hours. So this can actually be used in modern cities to basically ultimately helps the government to take suitable measures to reduce the air pollution levels that is taking place. So if we move forward now, these are the components that we have used for our project. We have used MQ135, PM2.5, MQ7 as the sensors, and we have used Arduino Uno, Node MCU, and for the software part we have used machine learning. We move forward. So this is the functional block diagram for project. So this entire project is divided into portion. One is the hardware and the software part. In the hardware part we basically use three sensors, which MQ135, MQ7 and PM2.5. MQ135 detects ammonia, carbon dioxide, smoke. MQ7 is used for carbon monoxide, and PM2.5 for particulate matters. So these sensors collect the data in real time. From there the data is sent to the Arduino Uno. From there we basically transfer it to the cloud server using TXRX modules of the Node MCU, and ultimately we make a data set upon which we basically feed the ML models that we have made. So this is the hardware part I've just explained, and these are the software portion that we have done. In the software part we basically are using supervised machine learning. So for that purpose we have collected a AQI data set, about label data set basically. Okay, and from that we basically perform the data pre-processing. Okay, data cleaning. Basically after the data pre-processing is done, we basically splitted the data into two portions: training and testing part. And these are sent to the individual models, and ultimately we get testing the models individually by using performance matrices like RMSE and R square, and finally we get the predicted model, which when we are getting the data from the sensors in real time, we get the predictable value of the AQI in real time. So if we move forward now, this is the calibration we have done. So the data which we get from the sensors, these are nothing but beat values, and we are converting those beat values to ppm, basically mapping them. So this is the flowchart which explains how the calibration process is done. First we basically read the beat values of the MQ135 sensor using analog read function. Then we calculate the analog voltage using this beat value multiplied by divided by 103. Then we calculate the sensor resistance, then ultimately calculate the coefficient by selecting a base resistance, and ultimately put those coefficient values in the ppm equation, which we get from the datasheet of the individual sensor manufacturers. So this same step is followed for the individual sensors. If we move forward now, this is how basically our model looks like. MQ7, MQ135, this is the Node MCU, this is Arduino Uno, this is the PM2.5, and all these are interfaced with this this is the things we cloud. If we move forward, yeah, this is how the graph looks like. This is about MQ135, this is the PM2.5. As you can see, these are the data that we're getting from the sensor in real time. Red one is for MQ7, green gives PM2.5, blue gives MQ135. So we move forward now. So this is basically a video. As we can see, this is the MQ7 sensor we have kept, and these are the readings we're getting from the individual sensors. This is the thing, as you can see, graph is actually being generated here. So if we move forward now, these are the results of the individual models. This is about the regression models. So we compared our model with the previous work basically done by Hemant Karnatis, and we can see that our model is more accurate. Better results are actually being obtained if we compare it from the previous work that has been done in this domain. This is about the regression part. We move forward. This is the classification part. Same accuracy and k-scores are taken, and you can see our model is pretty much better in performance if we compare to Hemant Karnatis score. So random forest regression is the best regression model according to our results, and the decision tree classifier has been found with the most accurate classification models. If we move forward, so yeah, with this we have come to the end.